Hi everybody, this is for those of you that were sick or gone for whatever reason during when we did shadows and distance. If you want a better idea of what we actually did in this activity, you can also go to the lab instructions page and you can actually get out the directions we watch for shadows and distance. But basically what we did is we set up 3 toothpicks at the end of our table, and the X's stand for those toothpicks. And that's where they were. So this is looking directly down on the toothpicks. And then we took our lights and first we held them very close to the toothpicks, and then we progressively moved the light further away. And we looked at what the impact was on the shadows that were made by the toothpick. And when it was really close, you can see light travels in a straight line and it strikes the toothpick, and we get shadows that are really fanning out and moving away from each other. But as we start to move the light further away, these lines are they're getting closer together and closer together. So what they're basically doing is they're becoming more and more parallel as the light is moved further away. Now, the last thing we did was just kind of a thought experiment, and it was based on this pattern. Now, remember, this is just what we had on our desk. So this would have been maybe 5 centimeters away. This would have been maybe 50, 60 centimeters away. This would have been, the length of the desk, maybe a meter and a half. The last question here was, well, what if with a light source were thousands of meters away? So really, really far in the distance, what do you think the shadows would look like? And we came up with this, that if we move it further away, these become more parallel. If it was really far away, they would look parallel. Now, would they ever actually be perfectly parallel? The answer to that is no. But they're so close to parallel that for all practical purposes, we can say that they are parallel. It's kind of like the idea in math where we say 0.99 repeating is equal to, and a lot of you have done this in math, got to get a pen that writes, 0.99 repeating is really equal to the number 1. And some of you guys have probably learned in math how to actually do that conversion. It's never ever actually 1, but it's so close that for all practical purposes it can be 1. That's the same with our idea of light shadows becoming more parallel as our light source is moved further and further away. So that's what we did, and you should now be able to, you can just copy this for the models that are on the paper, and then you can answer the questions on it. But the idea was getting to this idea of parallel here as we move the light further away. Thanks for watching, and good job doing your homework if you missed class.